Welcome to Weld.com, everyone. Today we're going to be talking about the sorcery that is Pulse MIG and all the nuances and weird things about it. Let's get into it. Now, as far as Pulse MIG goes, I would consider it probably one of the most versatile processes out there today as far as technology goes, and it dates back a little ways. It's just getting to the point now where it's a little bit simpler, because I think that's probably one of its biggest disadvantages is usually the equipment that you need is a little bit pricier. Same thing with the gas and everything, and along with the equipment and the gas being a little bit pricier, it's also a little bit more difficult to understand. The machine we're going to use today is the Cyclone 253 DPI. This is a single pulse and a double pulse MIG machine. Not only that, it does have all the other processes as far as your short circuit, and you can go through the transfer modes, but that's what Pulse does. It is kind of a regulator between those transfer methods. The easiest way I can explain it is it's like short circuit transfer and spray transfer had a love child. You get spray pulse. If we go through these menu cycles, you can see that it still has DC lift, DC stick, and we go through all of our other basic MIG functions until we get over to single pulse. When you go to your basic MIG or whatever we want, transfer method we want to work in, we set our inches per minute, which is our wire feed speed, aka our amperage, and we set our voltage as it's a constant voltage process. Now when we move over to single pulse, this is where you start scratching your head, because check it out, we've got amperage we set now instead of our wire feed speed, and we have something called arc trim, and then we have other things on here: start duration, start slope, start intensity, fill intensity. It leaves a lot to the imagination. So first off, before we can dive into setting a machine, we got to figure out more about Pulse MIG. Let's go to the whiteboard. Now I have to be honest, the first time I used Pulse MIG was back in 2015. About 10 years ago, one of my first welding jobs in pressure vessels was using Pulse MIG, but the machines were already set up for me. I just needed to know how to run it. It helps with a lot of metal transfer controls as we balance between short circuit and spray and kind of hang out in the globular and kind of go back and forth. This will help reduce fumes and spatter, higher wire feed speeds, and reduce heat input on the material. It's so versatile. You can weld thin metals, you can weld thick metals, you can weld any type of metal, whether you want to weld stainless steels, your aluminums, whatever it may be. You can do that with Pulse MIG. That's one of the biggest advantages, is it's actually preferred for alloys like aluminum. Another nuance to it is the arc trim. You have a switch on the machine that adjusts the trim. That's essentially changing your arc length. Not the contact tip to work distance, but the little arc length that's on the end of your wire to your plate. You can adjust that either up or down from 0, and that's going to affect your voltage and your arc length at the same time. It can control your arc stability, your bead appearance, fusion, or penetration, or it can ruin it if you're going the wrong direction. The biggest thing that we have to kind of deduce from Pulse MIG is the peak and background currents, what it's doing, the frequency, how often it's pulsing, all these things to go up into that spray transfer at its peak and drop that droplet of metal, and then come back down into, say, your short circuit transfer and help on the background side to keep a low current and maintain that arc. This is going to help do a lot of out of position welding. Your frequency is going to be changing how often that all happens, and you can adjust this for a number of reasons. Your width of that is going to be the distance from here to here or here to here, and that is just the time spent on either your peak or your background. And that's not even considered double pulse. Now, the way that it was explained to me is when we're doing single pulse versus double pulses, we'll be pulsing our voltage in single pulse, and we'll be pulsing both our amperage and our voltage in double pulse. And if you're looking to get just a little bit of a touch up on MIG welding or the MIG processes, I really highly recommend the American Welding program. We partnered with them, and we've got courses inside the American Welding program that has like basic wire 101. It goes through all the different types of filler metals, metal transfers, and Pulse MIG. Everything that I needed to kind of brush up on was right here in the wire 101 class in AWP. I really need to run over back to the machine because some of this does translate to that, but they've actually made this a little bit easier to understand, or I would say they took some stuff out so you don't have to. Alright, now coming back over to the Cyclone 253 DPI, we're going to start going over a little bit more of the hands-on stuff. We can get neck deep into the theory and kind of see what each one of those variables can actually control when it comes to Pulse MIG, but I'm a real visual, hands-on person myself, so I want to play with the machine and see what the weld does. That's what we're going to end up doing on some 1/4-inch T-plates, is just making some welds, seeing what these different things do when we change them, right? Starting off, looking at this left side, we have that arc trim. That's going to be, again, that arc length that you can change. It's a variable that you can change for a number of reasons. Do the increase, you'll have more arc length and more voltage. If you do the decrease, vice versa, right? So we're gonna have a -1 at this point. We're working on 1/4-inch plates, not super thick. I don't want a super big cone on it, so I would imagine I'd want a closer arc length. Start duration, start slope, start intensity, and pre-flow. The pre-flow and post-flow are obvious things that we're real used to that. And also the slope kind of to me sounds like obviously your upslope and maybe your downslope for like TIG and MIG. But all I have to do to kind of not necessarily forget about it, but if I just take it off and go to the 2T remote, I can kind of simplify things and not have to worry about it. The machine will do the base settings for it. If I want to do a little bit more involved, I can play with that. I think that would definitely help with starts and stops when it comes to probably automation specifically. Moving over here, we have the 2 and 4T remote, and then we have our inductance. The inductance is the same thing for short circuit or your spray MIG. You want to play with that. As far as what I was recommended was close to 40%. Burn back 0.3. Our pinch effect is going to control the size droplet off the end when we get into that spray transfer. So we're going to keep it modest, somewhere around 25%. I'm not really sure again what that's going to do to the weld itself. We're working with 035 size wires, 70S, standard torch. We've got our Abacore Benzel MIG gun on here, again with the consumables at 035. And then our shielding gas. You can run a number of shielding gases. This machine's going to recommend a 98.2 mix. We've got our Arcal Force gas right here, which is actually an 1882 mix. It's a really nice gas, and not only that, but of course the bottles are pretty slick with how easy they are to hook up. The best thing that I can say as far as setting your amperage, right, because we didn't necessarily talk about that, the nice thing is, at least where I'm going to start, is going to that power set mode, and then going down on this side and setting my wire size and my material thickness, again at 1/4 inch, and it's telling me 150 amps, give or take 10. So we're gonna go back off power set it to about 150. All we need to do now is just get suited up and make some beads. Got my PPE on, got my FR clothes, my camo gloves, my outlaw leather hood. I am ready to weld. I did forget to mention something that I mentioned on the whiteboard, which was peak and background current. Now when it comes to this machine itself, it's actually synergic pulse. In layman's terms, we're going to set our amperage as you've seen, which is our wire feed speed. Once we set our amperage and hit that trigger, it's going to start sensing that voltage, and once it does, it'll pick the peak and the background for us. As we're on single pulse mode, we'll be running that voltage up and down as far as the pulse goes. When we move into double pulse, it's going to be pulsing both our voltage and our amperage. I digress. We want to keep it simple right now, so I've kept it to the settings that I have. And of course, we can't make a good weld without some good clean prep. So I've got all of our plate prepped with the 3M fiber disc, and I think it's a good time to mention that Weld.com is going to be heavily involved this year in Clash of the Grinders as we go on being coaches and hosts for the show this year. I hope you all check it out. They're giving away some sweet cash prizes again this year. $15,000 for first place. Second place gets 10 grand. Third place gets 5K. If you want to learn about how to sign up for Clash of the Grinders, check out the link below. Got myself a comfy little seat here. Always be comfortable, baby, right? With the Pulse MIG, we're definitely going to be maintaining a push angle. It's not necessarily a drag process, not to say you can't do it, but it's recommended to have a push. No manipulation, nothing crazy. It's made to do its thing just by a straight push. I would say that went really well. Starting off at that 150 amps, that was kind of where the power set told us we needed to be. And that's a solid weld. There's like almost no spatter on it. It's not a lot of silica deposits. There's just a lot of good stuff about that weld. What I didn't like was the sound of it. It didn't sound like, still had kind of a crunch to it that I want to try to get out. I want to sound a little smoother. Let's see if we can adjust something. Okay, the only adjustment we made was a +1 to the arc trim. Let's see if that does anything crazy. Definitely got a further back arc for sure. Getting a little bit more undercut. Sounds really good. I don't know if we're getting it all filled in properly. I take a good wire wheel to that one to look at it. Now I've gone ahead and cooled this one off and took a wire wheel to it, and I think there's a clear winner as far as the weld here. This is the first one we did with the negative arc trim. This was -1, and then this is our +1. We just have a lot more undercut on that top side. We do have a flatter weld. That arc was a little bit wider, so it kind of gave us a wider weld, a little bit on that undercut side that I'm not a big fan of. But going up with that arc trim, that's going to probably increase our voltage regardless of what we want to do with the pulse. So we're probably going to have to increase our amperage to maintain that. I'm going to increase the amperage real quick to see if I can compensate a little bit for this undercut here. See if that helps. Let's try it. Sounds good. I think we got a little less undercut. It looks like, I think I know what I'm doing right and wrong here. Let's take a look at it. Now I actually made 2 welds on this coupon, one on the first side, which I got the arc shut up, but I didn't get this camera, so I went ahead and redid the other side. Might as well see what happens when we put a lot of heat into some 1/4" plate. Mind you, if we were looking at the power set feature, it recommended 150 amps for 1/4" plate. So we ran that at a hotter amperage, right? At least 1 bead on one side. This was what we got here. Remember, we turned our amperage up from 150 to 165, 15 amps higher than the first plate we did, and we still got a good solid bead here. I would argue that that one lays down really well. Might have just a skosh of undercut across the top of this toe here. When we get to that arc trim being further back and our arc length is further away, we have to be very aware of our actual push or drag angle. If I'm starting to push it, I notice if I push too much, I'm gonna definitely start getting undercut. And I noticed if my contact tip to work distance was varying, I started to see a little bit more undercut. And then we went ahead and welded that second bead on here, trying to maintain the same things. And I think I got a little bit more undercut. And I only really believe that that's the case, one, because we're working outside of the amperage range for this material, and the material was already really hot from the first weld we did, so we got a little bit more undercut. I think you probably can get away with a little bit more if we have our arc trim to the other side, at least for this thickness of material. Everything's all circumstantial, right? Situational. So again, working on 1/4" T-plates, I think the very first thing we did is right on the chili when it comes to single pulse, and it really wasn't nothing but setting it to 150 and running it. We had some inductance set and everything. I don't really want to dive deep into that, but what I do want to do is start with some double pulse and see what that's all about. Like I said, guys, I don't think I'm a pro at this Pulse MIG thing yet. We haven't tried anything out of position, and we didn't even try some of this other stuff when it comes to the remote. To keep things simple for today's video and not get too far in the weeds, we're going to move over to double pulse, and you can see we have a lot of those other bells and whistles that, quite frankly, I can't wrap my head around those yet. So what we're going to do is get rid of the 2TSP so that those kind of features all disappear. And again, having those on will probably help you fine tune a lot of things. I got to fine tune myself before I can start fine tuning this thing. We still have our capabilities of our arc trim. I want to go back to that -1, which was what we were working with in the first place, because that is what I believe to have the best weld so far. Now we have our pulse frequency. We can mess with the hertz here, our peak time, and our peak intensity. We were on single pulse controlling our voltage. Now the wire feeder is going to start acting up a little bit when it comes to pulsing at this point, and having it pulsing at a certain frequencies per second and a peak time, how long that wire is going to be stabbing, I'm assuming. And then same thing with that peak intensity, how hard it's going to be pushing that wire in there. I'm assuming these things. Now I think we have to play with it a little bit first to understand. We're going to try to pick one of the highers, the overs, unders on each one of these. So again, with the -1 on the arc trim, we go down, select our peak intensity. It only goes up to 50. Okay, so 25 is kind of in the middle here. Maybe we start everything on an average or a middle. Let's do that. Peak time goes up to 80, so let's try 40. And then I believe this goes up to 5, so we'll go to 2.5. Let's just see what these things do, and then after we see what they do, then we'll start changing those things. But our inductance, we're going to keep our inductance the same as we had on the other, which was somewhere around 40, 45. And as far as the pinch, this pinch effect is going to kind of control the size of droplet. We're going to keep it modest at 25. Again, I want to focus on these things at this point. Maybe we'll focus on that pinch a little bit after. Let's make some welds with double pulse. Alright, remember this is like a blind taste test here. I don't know what this is about, what flavor of weld I'm about to make right here. Let's give her a lick. Alright, just putting some ripples in there. I don't know if I like that or not. I feel like there's something we need to change. I associate that crunchy sound to inductance. So I'm going to try to mess with the inductance real quick. So I took my inductance from like 40 something to like 70. I think I went the opposite way for crunchy sounds, but half like 70, and then we'll turn it down like almost down to nothing and see what difference it looks. I kind of like the sound of this better. It's a little crispy on the punch side. This is really just to see what the inductance changes. It might be that we're not set up properly for our other variables on the other part of the double slope. But just so we can see what the inductance is going to do when we're doing this, we're at 70, now we're going to turn it down. We'll just do 10. Yeah, it definitely sounds way crunchier. I mean, I don't know, just off of sound, I like the way that the 70% sounded, but the look of the bead, I don't know if I'm indifferent or if I like the crunchier sound look a little bit more. Let's look at the welds. Now I think this coupon was more of an introduction to our double pulse and the inductance when it comes to the double pulse. This first side we did, that inductance, what, like 40 something? And everything as far as our settings were similar to the single pulse, except we added the double pulse. Not a bad looking weld, we got some ripples in there. And then comparing it to the other two, it's a tough thing to see the difference in these two welds. Definitely could hear the difference when it came to the, say, this percent up here. This was the 70% inductance. It sounded a little less crisp, where the other side sounded crispier. I want to say that we got less spatter on the 70%. I don't know, it's hard to say. It might be just an angle thing. And then the weld shape is just a little bit different compared to these two, but they're minute. But if you accompany that with some of the other variables that can help change the bead size, then you're really going to start changing things. Again, all this pulse and double pulse and inductance and all these different things that you can do to change a weld is they're minute, but if you stack them up, you can make some serious awesome changes. I really like the tie-in. It seemed effortless, and I bet if I turned on some of those starts and those upslopes, those slope buttons, all that kind of nonsense, I bet we can really fine-tune a tie-in. Anyway, let's move on to the next coupon. We played with the inductance. We're going to move that to at like 70, and then we're going to play with some of these other settings like the frequency and the peak time and peak intensity. All right, so we've moved the machine settings. We're still at 150 amps. The arc trim's still on -1. We've changed our frequency down to 1, so we're going to pulse less often, and we're going to turn up the peak time and the peak intensity all the way up, 80 and 50%. I'm hoping what this does is give me like some really solid freaking dimes here. I'm hoping that's what happens, but I have no clue if that's what. We're going to give her a lick. I don't know if I like that at all. It's definitely like shove and wire with that peak intensity. Oh, I still have the inductance down. That's what it is.
Oh, idiot.
Let me turn that back up to somewhere 60. We'll do 60. We'll get back into it. It's pulsing and it's putting like a really solid size weld on there. It's definitely convex. It's not a concave or a flush fillet. I did not get the big ripples I thought I'd get. I wonder how I can do that. All right, we went from 1 to 5 on the pulse frequency. So we just went from one extreme to the other. Lower pulse frequency isn't going to give me any ripples because it's just blending too much. Just looks like almost like a regular MIG weld. We'll see what this 5 does. Definitely doing something. It honestly sounds like a mess, but the bead looks good and there's like small spatter. Let's see if I can adjust the intensity down. So let's just go down on the peak time on. Instead of the 80%, we're gonna do 20%. Just messing with this thing, seeing what happens, you know? That definitely sounds like it's got more of a thump to it. Definitely going to that colder side of stuff maybe. Yeah, it was hard to say on that one what I liked. I think we were taking some extremes on both sides of the fence when it comes to that second pulse or that wire feed pulse. Whereas we went to like that pulse frequency, we had it down to like 1 and moved it up to 5. That's what you see here. There really wasn't a whole lot that I could tell. Then we changed the peak intensity and the peak time on. At this point, I've changed so many variables, it's hard to keep up with. I think that's one of the biggest challenges to this process is the fact that there are so many things to juggle and balance, minor adjustments that you can make, and visually you can only see so much. You're gonna have to eventually take it to some sort of testing, whether you wanna do a cross-sectional edge to see some penetration, do some fillet weld break testing, or if you have the capabilities of doing some tensile pulls, whatever it may take to get a little bit more data to see what each variable is doing. But you really don't even want to jump into that rabbit hole unless you have a project in mind that you have to accomplish and you need some proof. Moving into this last coupon, I say we crack it wide open and see what all the other features are and see if we can't make a decent weld that, you know, as far as the size and shape with the double pulse. So I changed my mind from my seat to this point here. I think I'm actually going to stick around single pulse for now. And the reason being is I don't think that the 1/4 inch T-plate is a complicated enough weld to have to whip out a second pulse. I mean, it's such a simple weld, it doesn't need complicated settings. So I'm going to stay away from those because I don't know if I'm going to do any harm or good when it goes to jumping into these other settings over here. So we're going to start with the start duration. If you could compare it to anything, it's like a, you know, an upslope or a hot start. We're going to keep our arc trim the way we liked it before. As soon as I can navigate this screen here to -1, we know we like that weld. I'm not going to touch the pre-flow, I don't really care. Nah, fine, I'll touch the pre-flow. 0.2 seconds. Start intensity, 70 sounds cool. You got to turn down our amperage down to 150 so we're not working up in those other trim ranges. Start duration, we'll just say that like 0.2 seconds. I don't want to sit there and want to do that forever. Start slope, 0.2. Let's go down. For post flow, we'll add a little bit more seconds, about a half a second. Fill intensity. We want to up that intensity similar to what we have with the start. And again, these are me guessing, guys. I'm just shooting in the dark here. And then that slope, I want it to taper down a little bit longer. So we'll say a whole half a second there. Let's see what happens, right? We know what the other pulse settings did for us. Our inductance is all the same. We're still going to make that same weld that we talked about earlier. We're just going to see if we can have that up and down honed in a little bit more. I suppose it was bound to happen. I would miss those last 2 arc shots on this piece of plate, but we can still look at the welds regardless. We went back to single pulse MIG and we were playing around with a little bit of the fill and the start durations. I think that did help as far as our starts and our stops compared to right here. We have a little bit more of a filled in crater, if you ask me, right in here. It's a little stacked, a little higher. I don't really see a huge difference in my start here. Maybe it was a little bit smoother to kick off. I didn't really see a huge difference in this first bead that we made with the 25% pinch point. It sounded a little different. This one, I don't know. I don't know if that means those bigger droplets just were more beneficial. It just sounded better to me, you know? So that's the only thing I can really compare it to. Again, this whole Pulse MIG thing, there's all these little nuances that I keep talking about that if you start to stack them the wrong way, you're gonna get just the absolute wrong weld. But the best way to go about it, going and push it to its limits till you see that you don't like it, you don't like the way it looks, sounds, whatever it may be, then change it, right? Play with it. You gotta do some testing before you jump in on anything. That's all the time that I got today, folks. I hope you took some value out of it. I know I did. Getting familiar with this Cyclone 253 DPI has been really helpful. I don't know if I am ready for double pulse yet. Still have to figure out the single pulse. Let us know down in the comments what you'd like to see as far as experimenting with Pulse MIG here on the channel. Remember, this Pulse MIG can run a lot of different wire too. It could run aluminum, stainless steels, aluminum bronze, carbon steel. You can do so much with this process. That's why it's important, I think, that we cover and do some experimenting. Let us know down in the comments. Not only that, but find the link in the description below for this machine and Clash of the Grinders coming out later this year. We're giving away $15,000 cash to first place, $10,000 to second, $5,000 to third. Go down right now and sign up and register to see if you get selected to be on Clash 2025. We'll see y'all on the next weld.